We're going to take just a minute or two here to go over some theory of BGP peering before we actually start performing it. And this is very important stuff. You're going to see it's very simple stuff, but it's very important because, of course, without the peerings, we really don't have anything else going on. But also, we have to watch what kind of peerings we have because that's going to impact the operation overall of our BGP deployment. TCP, just like TCP, BGP is connection oriented. It's considered reliable. And we're going to have an underlying connection between two BGP speakers before the routing updates are actually exchanged. Now that connection takes place on TCP port 179, which is a port you've got to leave unblocked by access lists or anything else you happen to be blocking stuff with on your Cisco routers. Once that connection is established, the BGP speakers exchange routes, they're going to sync their tables, and then after that, the initial exchange, that is, a BGP speaker sends further updates only when there is an actual change in the network. Now, BGP speakers do not have to be in the same autonomous system in order to become neighbors and or exchange routes, as we're going to see in just a moment. We have two different kinds of peerings, and this is what you got to watch. Our adjacencies, we can have an internal peering or an external. Now a BGP peer in the same AS as the local router is an internal BGP peer, just like we see here on the board. Both routers are an AS 100. That's an IBGP adjacency. And a BGP peer in another AS is an external peer. Makes perfect sense, nothing difficult there at all. But you got to watch that little I and that little e, because that's the way it's going to show up sometimes in your BGP tables and also in the diagrams that we're going to be seeing throughout this section. Cisco recommends that eBGP peers be directly connected. IBGP peers are not required to be so connected and generally will not be. Now we're going to start our very first adjacency here in our first lab with the router BGP command, followed by a neighbor command to identify this BGP speaker's potential neighbors. So let's go ahead and bring the live equipment up. And we're on router 1. Routers 1, 2, and 3, by the way, are over the same frame relay network that we've used over most of the labs in this course. But I'm not showing it here because it's really not germane to what we're doing. We're looking above that. We're looking strictly at BGP. So router 1, let's start there. And with router BGP, we have one option and one option only, and that's the autonomous system number. For our lab here, we're going to put router 1 in AS 100 and router 3 in AS 300. Actually, that's actually an example. Let me go right down here. This is the adjacency we're going to build. And it's an eBGP adjacency between router 1 in AS 100 and router 3 in AS 300. So we start here with 100. And looks pretty familiar so far, right? Looks familiar. And we're going to do our neighbor command here. And we've got an address or an IP version 6 address or a tag. We're going to stick with our traditional version 4 address for right now. 23.3. And holy cow, that's a lot of options. And you'll notice we're only through the P's. Do not panic. You do not have to know every single one of these for the route exam. I'm not even sure you have to know every single one for the IE lab. There's some stuff in here that I haven't used, and I've been using BGP for an awfully long time. And let's look at a couple more options here, but notice the one thing you don't see at the bottom is a CR. So you've got to put something here. You don't just put a neighbor command. And one of the requirements, the requirement really for a BGP deployment, you got to specify the neighbor. There's no dynamic discovery here. You've got to specify the AS of this neighbor that you're entering. So we're going to put remote AS, and again, you've got to put the AS of the remote neighbor, which is going to be 300. Now we know that this adjacency is not complete because we haven't gone to the neighbor and done anything as far as BGP config. But what I want to show you right now is your first verification command, which is show IP BGP neighbor. And you can also follow that with the IP address of the neighbor if you just want to see this information about one. And that can come in handy when you have a lot of BGP neighbors. But looking at top to bottom here, BGP neighbor is 172.12.123.3, makes sense. There's the AS number of the neighbor, and it's an external link. Okay, so far so good. BGP version 4 is what we're running. And there's no RID here indicated for the remote router because we know we don't have an adjacency. There's no way to have a RID. Notice the BGP state of active. Sometimes, as we've seen, active is good, and sometimes active is bad. And there are some other BGP states that you might not see here during these labs, so I want to show them all to you right now. And this is important stuff because it really helps you spot the issue. And first off, our states, we start with idle, and that's the initial state of a BGP peering. And if you have a connection that goes to idle and stays there, I can practically guarantee you it's going to be one of these two things. 99.9% of the time, it's going to be one of these two things. Make sure that the IP address in the neighbor statement is the one you meant to use. I know that sounds silly, but everybody mistypes a number sooner or later. I do it, you do it, everybody does it. Make sure the IP address in the neighbor statement is correct, because you're going to spend 20 minutes one day troubleshooting the complicated stuff, and then you're going to come back to that and say, oh, I can't believe it was the neighbor statement. Check that first. Be sure the local router knows how to get to that particular IP address, because I have a feeling in some of our more advanced labs in this section, reachability may be an issue. Here it's not an issue because they're all on the 172.12.123.0/24 network. Now connect follows idle. Now in connect state, a TCP connection request has been sent, but a response has not yet been received. Now if the TCP connection completes, BGP will move to what we call open sent. If the connection does not complete, the state goes to active, and that's where we are right now. You'll only see connect if you happen to run show IP BGP neighbor at the right time. It's not going to stay in connect state. It might go to idle and stay there for the reasons we talked about, and it might go to active and stay there because we're seeing that right now. Active means the BGP speaker is continuing to attempt to create a peering with that intended neighbor. And basically this is the halfway point of the connection. The local router has successfully sent a BGP open packet to the potential neighbor, but it hasn't heard anything back. And that makes sense because we're on router 1, we've configured BGP, we've got a remote AS statement, everything's good there, but we haven't gone to router 3 to finish. So it makes sense that this is the state that we're in. As with idle, there's nothing wrong with seeing active for a few seconds, but when you see your connections stay there, then you've got a problem. In this case, first off, make sure that you have BGP configured on that neighbor. Check the remote router's neighbor statement, make sure the AS numbers are correct. You've been taught so often with EIGRP, you know, the AS has to be the same, the AS has to be the same, the AS has to be the same. And sometimes when you're starting with BGP, you'll enter the same AS as you just put on that remote router, even if it's not the one you're supposed to put on there. It's a hard habit to break. Now, open sent, that indicates the BGP speaker has received an open message from the peer, and what BGP is doing at that point is determining whether the peer is in the same AS or a different AS. Open confirm has the BGP speaker waiting for a keep alive. If one is received, the state moves to established, and that is the end game. That's what we want, the established state, because it's in that state that update packets are finally exchanged. So with all that said, let's go back to the live equipment, and I want to show you something here at the very bottom of this output, and some helpful information here. Connections established 0, so we've never had one. How many have been dropped, when the last reset of this connection was, and we're being told no active TCP connection. When we see this, we know there's an underlying issue, period, and there's no use to get complicated with your solution. We're going to fix this in just a moment by going to router 3 and finishing the config. When you have resolved the no active TCP connection issue, you're going to see a ton of extra information here. This is a verbose command when everything is up and running. So speaking of that, let's go over router 3 and make everything up and running. Router BGP, we know this is an AS300, and our neighbor 172.12.123.1 remote AS100. And let's see if something good happens. Something good happened right there. There's our BGP message. Adjacency change, neighbor 172.12.123.1 up. And up is always a good thing. So let's run show IP BGP neighbor. And again, just a quick reminder, if you want to filter this output, put the one IP address in there. and you're gold. Now, let's see, going from top to bottom with show IP BGP neighbor, there's your neighbor ID, IP address, remote AS. This is an external link. Notice now we see a RID for the remote router. That's always a good thing. And here's what we really want. BGP state equals established. And right now it's been up for 21 seconds. And we go to the bottom and you'll see some information here. Is IPv4 unicast. And notice now where we see connections established 1, dropped 0, last reset never. You don't see, just TCP is enabled, the connection is enabled. You're going to see a lot of extra information. Local host and foreign host. Foreign host, that sounds kind of aggressive. We're supposed to be peers and neighbors, and here we are with this foreign host stuff. Well, the important part is there's your local port 179 information. That's the port that was used to get the whole thing started, and you've got to leave that unblocked by everything. So right now we are up and running, and I'll go over to router 1, show IP BGP neighbor 172.12.123.3. And we see the exact same information. And again, there's the important part right there. BGP state equals established. And this is what we got to keep our eye on, that external link. So we're looking good. We've verified our first adjacency. After building our first adjacency, everything looks good there. And this is where we're headed next. We're going to bring router 2 into the mix, but we're going to put router 2 in the same AS as router 1 and then build from there. See you on the next vid.